All right, so let's take a look at question 20 from the 2024 Advanced Maths HSC. So we're given some information about a tower, a point due east of the base of the tower, and another point which is on a different bearing. And then all of this information is summarized in a diagram. So we are asked to show distance AC is 57.13, correct to 2dp. All right, for part A, if we draw the triangle TCA, it is a right angle triangle with a height of 40. So this is TCA. This angle is 35. We can actually use SOHCAHTOA to find the base here. So we want AC down the bottom. So this will be tan. Tan 35 is equal to opposite over adjacent, 40 over AC. If we rearrange this for AC, we get AC is 40 over tan 35. You put this into the calculator, you get 40 over tan 35. Make sure calculator's in degrees mode, and we get 57.1259 dot dot dot. So this is 57.13 to 2 decimal places. So this is what we're asked to show for part A. Part B tells us to find the bearing of B from C to the nearest degree. Right, so this, we have to think about the aerial view of this situation. So if we look at the tower from above, T and C are on top of each other here. This is both T and C. A is due east. The question tells us point A is due east of the base of the tower. And this distance we just calculated was 57.13. Point B is on a different bearing. It looks like it's sort of down here relative to TC if we were looking at it from an aerial view. So this is 100. Now the question asked us to find the bearing of B from C. So given that this point here is C, that is whatever this angle is. So based on our sort of rough drawing, the bearing we're after is something like 200. So if we get a bearing once we finish this question that's, plus minus 20 of 200, then it's likely correct. We know this angle is 90. We just need this angle in here, which we'll call theta. Now we've got this side, we've got this side. We just need this missing side over here, connecting C and B. TCB, conveniently, is also a right angle triangle, and we can use tan rule again in order to get BC. So we do tan of 30 is opposite over adjacent. That's 40 over BC. So this means BC is equal to 40 over tan 30. 40 divided by tan 30. My calculator tells me this is 69.282 dot dot dot. We'll round this to 2dp. 69.28 bracket 2dp. There's precedent to do this because the question told us to do this in part A. So we're going to do it in part B as well, and it should not affect the angle. 69.28. Now we can use cosine rule. So the cosine formula, non-right cosine rule, is going to take the form cosine C. Now the cosine rule actually has a few different forms, and depending which one you've learned will depend the one you use. The one on the formula sheet, the advanced maths formula sheet, is the form cosine C equals. So we're going to use that one. So cosine of capital C is equal to A squared plus B squared minus C squared over 2AB. So this means cosine of capital C, which in our case is theta, is equal to, these are A and B, so we get 69.28 squared plus 57.13 squared minus 100 squared. This down here is lowercase c, all over 2AB. Now A, we said, was 69.28, B 57.13. So now we need to evaluate all of this. So this should come out as minus 0.2446 dot dot dot. And if we take the arc cos of this, arc cos of minus 0.2446, we get 104.158. So this is 104.15 dot dot dot. So the bearing in question from C to B, given that C is here and B is here, is 90 plus theta. The bearing from C to B is equal to 90, the right angle, plus the angle we just calculated, 104.15. This ends up being 194.15 dot dot dot. Question says nearest degree. So this is 194 to the nearest degree. And this is the answer to question 20.